Chapter 11, Section 2, page 2. We will start with Exercise 3. The information is given about a certain sphere, and we need to find the equation of that sphere. First of all, we will begin by finding the center of the sphere. Note that the midpoint of the line segment, which is the diameter in this case, connecting P1 and P2, is found by finding the average of each of the coordinates. A midpoint is the same thing as an average. So the midpoint of the x-coordinates, or average of the x-coordinates, is 1 plus negative 4 divided by 2. The midpoint, or average, of the y-coordinates is negative 2 plus 6 divided by 2. And of the z-coordinates, 3 plus negative 7 divided by 2. This is a point in 3 space. Negative 1.5 to negative 2. Next we find the radius, and that is half of the distance from P1 to P2. So we have 1/2 the square root of the following. Just like the distance formula, which I am sure you are familiar with from 2 dimensions, we subtract the x-coordinates in any order, square, plus subtract the y-coordinates, square, plus subtract the z-coordinates, square, and you get 1/2 square root of 189. Now the equation of the sphere is set up in a similar manner to the equation of a circle. We have x minus the x-coordinate of the center squared plus y minus the y-coordinate of the center, that's 2 squared, plus z minus the z-coordinate of the center squared equals the radius squared. Simplifying, we get the following: x plus 1.5 squared plus y minus 2 squared plus z plus 2 squared equals 189 divided by 4. Continuing with a few more notes and definitions. In three-dimensional space, vectors are denoted by ordered triples. V equals V1, V2, V3. We use these pointed brackets to denote a vector. So this would be the 0 vector in 3 dimensions. The standard unit vectors are the following: I, 1, 0, 0 in pointed brackets, J, 0, 1, 0, K, 0, 0, 1. The word unit means having length 1. Now, if a vector is given by V equals V1, V2, V3 in this notation, we can also write it in standard unit vector notation. And that would be V1 times I plus V2 times J plus V3 times K. The norm of a vector, given as you see, is also called the magnitude or length. Notice the notation double bars around the vector V is computed by squaring each of the coordinates, adding those results, and taking the square root. A unit vector u in the direction of V is the following: u equals, you often see this notation. However, there really is no definition of a scalar being divided into a vector. So the absolutely appropriate way to write this and what it means is 1 divided by the magnitude or norm of v times the vector v, because we do define a scalar times a vector. Now, it's a fairly simple proof that this entity here, also given here, has length 1 or norm 1. That it also has the same direction as a vector v is noted by looking at the fact that it is the vector v multiplied by a positive scalar.